So in this video we're going to look at circle theorems. Okay, so these are the circle theorems that you need to be aware of at Leaving Cert Ordinary level. So just before we get into the actual theorems, there's a couple of little things I want to talk about circles, just to recap, okay? So a couple of little notes. If you have a line going from the center to the circumference, it is of course called a radius, okay? Also, if you have a line that's going from one end of the circumference through the center to the other end, that is called a diameter. Okay, and the relationship, of course, between a radius and a diameter is that the diameter is double the radius. Okay, so the other little note I want to add here is if you have a line going from one side of the circumference to the other side of the circumference, but not through the center, okay, it is what we call a chord. All right, so just a little bit of terminology there before we get into our theorems. The other thing that's really useful to point out here is this. If you have the following diagram in your exam question, you have a little triangle like this stemming from your center, then what they won't highlight and emphasize to you, they'll assume that you will know, is if you have obviously this line here going from the center to the circumference, it is a radius. And if you have a line here going from the center to the circumference, it is also a radius. So what you end up having here is a particular type of triangle. You have a triangle with two equal sides, okay, which is called an isosceles triangle. Now they won't put these dashes on the lines here to let you know that these are equal. Unlike how they will do it in other geometry questions, they will always let you know with little dashes what lines are equal. In the circle, they won't put these dashes here because they'll assume, well, you'll spot already that that's a radius and that's a radius. So watch out for this. Anytime you have two lines coming from the center to the circumference, if they are both radii, then they are both equal. So look out. Isosceles triangles. Look out for isosceles triangles. And the important thing about isosceles triangles, of course, is that two sides are equal. In this case, because the two radii, and your two base angles are equal. Okay, and that means that this angle here is equal to this angle here. Okay, so watch out for that. As I said, it won't be given to you really clearly with dashes. You'll have to just watch out to see if you have an isosceles triangle or not. Okay, so we're just going to jump straight into one of the theorems then, and this one you might be familiar with from your junior cert. So this theorem states that the angle in a semicircle is a right angle. So what I would suggest is don't worry too much about the blurb with the theorem. The key thing is the diagram, all right, because that's most likely how it's going to come up for you in the exam, is through a diagram. So be really clear on the diagrams more so than the actual wording, okay? So looking very clearly at this diagram, whenever you see a triangle where your diameter is the base, then the angle at the circumference up here at the top will always be 90 degrees. Okay, that's what's key here. The next theorem I want to talk to you about is this one. So the wording of it is that the perpendicular from the center of a circle to a chord bisects the chord. Okay, so let's explain that. So we have a line coming down here from the center, and it is at right angles with this line here, which we know is called a chord because it's going from one side of the circumference to the other and not through the center. So this is a chord. If a line comes from the center and is perpendicular to the chord, this theorem states that it will bisect the chord. Now, what the word bisect means is it will cut the chord equally in two. Okay, so that's why there's two dashes here on either side to show that that line must equal that line if you know this line from the center is coming at 90 degrees from it. So the perpendicular from the center of a circle to the chord bisects the chord. It cuts it equally in two. So this line is the very same as this line. Okay, the next theorem we want to talk about, and there's two parts to this, but again, don't worry too much about the blurb, more so look at the diagram, okay? So the first part says that a tangent is a line that touches a circle exactly once, okay? So there's just one point of contact. And this says that the tangent is perpendicular to the radius when it touches the radius, okay? So if you have a tangent meeting a radius, it will meet it at 90-degree angle, always, okay? So a tangent meets a radius at 90 degrees. The second side of this theorem is that if you have a point here and you know that it is perpendicular to the radius, then if you know that that angle is 90 degrees, then you can be sure that that line is a tangent. So they're both looking at the same facts around this theorem. It's just the first one is just saying that if you have a tangent, it will meet the radius and it will be perpendicular. So the tangent meets radius, then it will make a 90-degree angle. Okay, but this one's saying then if you know that you've got a 90-degree angle, then you can say for sure that the line must be a tangent. Okay, and the last thing I want to point out, this is a corollary. And a corollary is just a statement that's attached to a theorem, which has been proven and also follows obviously from it. So it's just something that follows on from a theorem, okay? So it's just an extra thing, again, to be wary of. And again, don't worry about the blurb, it's more the diagrams, okay? Be very familiar with the diagrams. That's how it will come up most likely in the exam. So what this says is if you have two circles touching, intersecting at one point only, then the line between the two centers is going to be a straight line, okay? And that's what this means, that they are collinear, which means the 2 points are along the same line, okay? And likewise, if the circles are touching and it's kind of like an internal intersection, one is inside another, again, there's only 1 point of contact, still those two centers will sit along the same line, all right? So that's what that little point is saying. Okay, so they are all the important points about circles that you need to be aware of. It would be a very good idea for you to draw all of those diagrams with all those important points on one sheet for yourself. As I said, the diagrams are more important than the blurb. The blurb can be a little bit confusing sometimes, but the diagram will be a lot clearer. And it's the diagram, as I said, which will most likely be the way it'll come up in an exam paper. So let's have a look at some questions together. Okay, so here we are looking for the angle A and the angle B. All right, if you'd like to give this one a go yourselves, press pause and see how you get on. Otherwise, watch through now and I will talk through it clearly. So one of the things I asked you to watch out for is whenever you have lines coming from the center to the circumference, these are all radii, which means those three lines there going from the center to the circumference, center to the circumference, and center to the circumference, those three lines therefore are all equal. So that means we've got two isosceles triangles here, which means that the base angles are equal. So if I was to turn this around for myself, I could see that if those two lines are equal, then it's those two base angles that are equal. So straight away, that means that A is 42 degrees. And then I also know if you look at the bigger triangle, okay, in the bigger triangle, where my base is the diameter, that whole angle up at the top must equal 90 degrees. So if that whole angle is 90 degrees, then if I take A, which is 42, away from 90 degrees, I get 48 degrees, which means that angle there is 48. And if that angle there is 48, and we have an isosceles triangle here, then that base angle 48 must be equal to that base angle B, so therefore B is equal to 48 degrees. Okay, let's try this question. So in this question, we're given a circle, center O. We are told that we have a perpendicular line OM, and we can see we've got the little 90-degree angle symbol in there. OM is 5 and OB is 13, and we're asked to find the length of AB. Okay, so if you've spotted already, the theorem at play here is the theorem that states that a line perpendicular from the center will bisect a chord. So we know that that's length is going to be equal to that length from the theorem. Okay, pause the video if you feel confident to be able to do this one on your own. Otherwise, listen along and we'll go through it now together. So what I need to figure out is, looking at this little triangle here, what I have here is, of course, a right-angled triangle, where that's 5 and that's 13. And if I figured out this length here, I'm just going to call it x. If I can figure out that length, then to get the total length from A to B, I would just add it to itself, because those two lengths are the very same. Now, when you have a right-angled triangle and you're missing a side, we can use Pythagoras, of course. So Pythagoras is c squared is equal to a squared plus b squared. Of course, the c always has to be the hypotenuse, the side opposite the 90 degrees, or the longest diagonal side. So 13 will go in there. And then the other two sides can be filled in either way around, it doesn't matter. So we'll put x in there and 5 in there. And then evaluating that, I get 169 is equal to x squared plus 25. Now, then I'm going to take away 25 from both sides, okay, and that will give me the x squared on its own. And 169 take away 25 is 144. And now to get from an x squared to an x, I'll square root 144, and that will give me 12. So now I know that this length here is 12, and of course this length here must also be 12. So the length of AB is going to be 12 plus 12, which is 24 units. Okay, let's take a look at this question. So here we have a tangent. So immediately what should be coming to your mind is the theorem that is connected with a tangent to a circle. And the theorem states that a tangent meets a radius at 90 degrees. And that means that x add y is going to be 90 degrees. Okay, straight away we have that theorem at play. Right, press pause if you feel you are confident enough to do this question. Otherwise, listen along. So what else do we have going on here? So again, the other important thing I said to you to watch out for is wherever you might have radii. Okay, so I have a radius here from the center to the circumference, and I have a radius here from the center to the circumference. So straight away, those two lines are equal, and we've got an isosceles triangle here. So if we've got an isosceles triangle here, and obviously the three angles in a triangle must always add to 180, okay, that's one of our basic geometry angle facts. Well, if I take 120 from 180, then I get 60 degrees. That means the two angles here and here must add to 60 degrees, okay? And since it's an isosceles triangle, these two base angles must be equal, which means then if they're both adding to 60 and they must be equal, if I divide by 2, then I'm getting what each of those angles are. So therefore x is equal to 30 degrees. So that's 30 degrees. So now I've already said that the two angles x and y must add to make 90, because we know that a tangent always meets a radius at 90 degrees. So therefore 90 take away 30, which is 60 degrees, will give you the value of y. Okay, let's take a look at this question. This is the second last question we're going to look at together. So why don't you press pause and see how much of this one you can get yourselves first. Okay, so let's take a look. So PT is a tangent to the circle. So straight away, what do we know about tangents to circles? Well, our theorem states that a tangent meets a radius at 90 degrees. So straight away, I'm going to put that little bit of information in there for myself. That is a 90-degree angle. So we have two 90-degree triangles there. We've got that larger triangle, ATP, and we also have this smaller right angle triangle, OTP, as well. Okay. All right, what else? So we have the 70 degrees and the 40 degrees already put in there on our diagram. The first thing they're asking me to find is the angle OPT. Now the angle OPT is this angle here that I'm looking for, okay? So OPT, that's the first one I'm looking for. Well, since I've already spotted that that's 90 degrees, all I need to do for part I is take away the 90 degrees from 180 and the 70 degrees from 180 because the three angles in a triangle must add to make 180. Therefore, when you take those two angles away, you're going to be left with 20 degrees, which is the angle OPT that I was looking for. Okay, so I'll put that in as 20 degrees. Now we're looking for angle OPA. So let's see where that is. OPA. So now we're looking for this angle here, up at the top as well. Okay, so what else do I know? Well, I've got a straight line here. Okay, so again, going back to your basic geometry angle facts, angles along a straight line must always add up to 180. So 180 take away 70, which is 110, must be this angle here. And now we have a triangle here, of course, and the three angles in that triangle must add to 180. So if I take those two angles away, I'm going to get 30 degrees, which must be then the remaining angle up here. Therefore, angle OPA equals 30 degrees. Okay, this is the last question we're going to look at together. So press pause and see how much of this one you can work out for yourselves. Okay, so ST is a tangent to the circle. Okay, so if it's a tangent, what do we know? We know straight away from the theorem that a tangent meets a radius at 90 degrees. So that tangent, the angle between the tangent and that radius there, is 90 degrees. So I'm putting in my box to denote that that's 90. We know that that little angle there is 40 degrees. That's put in for us already. And now we're going to find the first part of the question, which is angle OST. So angle OST, oh well, I've already put that in. That is, of course, 90 degrees. So we know that already from our theorem. Jumping to part 2, angle OSP we're asked about. So OSP now is just this little section here. Okay, so now, well, if you know that the whole thing is 90 degrees and you know from there to there is 40, then 90 degrees take away 40, which is 50, must be that angle OSP in the triangle 50 degrees. Okay, part 3 then, angle OPS. So OPS is now this angle here that I'm looking to find out. Now, what have we got? Again, the other thing to look out for is we have a radius there and we have a radius there. So we have an isosceles triangle, of course, here, which means the base angles are equal, which means if that's 50 degrees, that's also 50 degrees. So straight away, we know that that angle OPS is 50 degrees. And the last part, part 4, angle SOP. So SOP is now this angle at the top in that isosceles triangle. Well, if the three angles of the triangle add up to 180, and that's 50, and that's 50, then what do I need to add up to 180? Well, let's take away the two angles that I have, and of course I get 80 degrees. So that angle SOP is equal to 80 degrees.